relationship between areas of similar figures. That's it. We'll work how to do it one way and then we're going to work backwards. That's all we're doing today. Do you guys remember what a similar figure is or what makes them similar?
Same shape, different size.
Same shape, different size, and we're going to use ratios. Perfect. You guys nailed it. So this first part of our notes is just for us to figure out the pattern, okay? Because we're going to see a pattern and then we're going to use the pattern to solve problems. So if we look here, it says what's the scale factor? Remember, that's just picking two sides that match and writing the ratio between them. So it looks like we're putting figure B first for these ones, so we'll keep the order the same. So if I pick a side on figure B, which one do you guys want to use? 5K? Okay, so we're at 5K over. Now what does 5K match on the other figure?
5.
5. And then we always just want to reduce. So what would that reduce to?
K over 1.
K over 1 or just K. Yep, perfect. So that's our scale factor. Now we want to look at our perimeters. So this looks like it's a rectangle. This should probably give us more information, but we know that opposite sides are the same here. So what would the perimeter of B be? Right, should be 28 if we add them all up. So 28K. What about figure A?
28.
It is 28. And if we reduce that, what do we end up with?
K.
So if we notice our scale factor is the same as the ratio of our perimeters, that's fun. Now let's look at our areas here. What's
45.
Yeah. For figure B, be 45. K
squared.
squared, right? K times K is K squared. And what about 9 times 5?
45 squared.
Yep, 45. And if we reduce that, what do we get?
Just K squared.
Just K squared. So if we look here, is there any relationship between the scale factor and the ratio of our areas?
It's just K.
K, and then how would we get to the ratio of your areas? What would you do to K? You just have, we just square it. So that's kind of what we wanted to take away from this. If you know your scale factor of similar figures, you know your scale factor, we can find the ratio of our areas. That's how we're going to abbreviate that. So if we say this is A and that's B, so if we have A over B as your scale factor, to get to the ratio of your areas, you just square it. A squared over B squared. That's what we're doing today. So on this first one, we have two similar triangles and we're looking for the area of our bigger one, okay? So we know the area of triangle JKL is 30 and we're looking for the area of triangle PRQ. So what we can start with, since we have matching sides here, is our scale factor. And I like to do a little road map. So I'm going to start with my scale factor. What would that be?
12 over 15.
Yeah, I like to put that smaller one on top just because, I don't know, my brain works that way. And then to make your life easier, always reduce if you can. And if you don't remember how to do it on your calculator, 12, the ABC button, 15. What are you guys getting? 12, then the ABC button. Yep, and then 15. 4 fifths. We're just reducing, just because you'll get some bigger numbers later on, you're going to want to remember how to reduce it. Oh, so you have answers. Why don't you pick down at 12? ABC, 15. You guys okay with 4 fifths? Okay. So now that we have our scale factor of 4 fifths, we want to go to the ratio of our areas. So if this is our scale factor, what do we do to it to get to the ratio of your areas? Square it, right? So what's 4 squared? Yep. 5 squared? Beautiful. So now that we know the ratio of our areas, we can use this to help us write a proportion to solve for our missing area. So we're going to have 16 over 25 is equal to, we we were told that this one has an area of 30. Is that your smaller or bigger triangle? So where is that going to go on your other side here? Top or bottom? Because it's with a smaller number. 30 over x. You guys remember how to solve a proportion? Cross multiply. 16x equals 750. You're getting like 46.9 inches squared. What you guys got?
Yeah.
Okay. Let's try another one. Same thing. We have similar figures and we're looking for the missing area. So we'll start with our scale factor. What would that be? 5 over 8, yep. These sides match, so 5 over 8. Now we have to get to the ratio of your areas. What do we do to our scale factor to get that? Square it, right? We said 5 squared is 25. What's 8 squared? Beautiful. And then from there, we write our proportion. So 25 over 64. Okay, we know the area of the blue one's 32. Where does 32 go on our proportion? Bottom, right? So it's the bigger figure. 32 on the bottom, x on top. Okay, let's see here. That's what I got. Anyone else agree with us? Come on, you guys get a head start on that last one. Same process, just different numbers, and I'll put you on the board. Start with the scale factor. You guys get 24? Okay. When you're ready with that one, let's go to the back or the next page. We have two going the opposite way. The reverse order. So now this time, you guys see how we know both of our areas? And we're trying to figure out the side length or the scale factor? So this time, we have to start with the ratio of our areas, because that's the only thing we know of both. Okay? So I'm going to write 50 over 72. Now this is where you really do want to reduce them, because they're almost always going to give you nice perfect squares at this point. So what does 50 over 72 reduce to? 25. Right. Then from here, we want our scale factor. So if this is a squared over b squared, how do I just get a single a over single b? What do you have to do to something squared?
Square root of it.
Yeah, we have to take the square root of it. So what's the square root of 25?
5 over 6.
Yeah, there you go. Now we can write our proportion. So we'll have 5 over 6. Okay, so now if we're looking for x, where's x gonna go? Top or bottom?
Top.
Yep. It's kind of a goofy problem, right? So you're just getting 5? Yeah, kind of weird. We found our variable to be 5. And then they want the scale factor from the blue to the green figure. So what would your scale factor look like?
5 over 6.
On this one on top, so 5 over 6. Okay, last one. Starts the same way, ratio of your areas. 64 over 400. What is that reduced to? What's that? 8 over 50?
Wait. Oh, alright, sorry.
So we'll check. 4 over 25? 4 over 25? It's okay. Then we want our scale factor.
2, 5.
Yep, square root of these guys, perfect. And now we can write our proportion. So 2 over 5.
X over 5.
Yep, x is on top, so it's the smaller one.
Yeah.
Mm-hmm. Over 40. Cross multiply. $16. Now careful on this one. Again, scale factor, blue to green figure. What would that be?
2. Oh, blue to green?
Blue
5
to
over
green. So if we found x to be 16, right, it'd really be
Oh.
like 40 over 16, but then we want to reduce it. How does that reduce?
5 over 2.
Yeah, it should just really be this flipped, right? 5 over 2. Perfect.